Hello and welcome to ABC Foundation's third webinar in our Carbon Farming Outreach Program webinar series. Today we're going to be looking at climate change. Before we start, I'd just like to acknowledge the Whadjuk Noongar people, whose country I am on today, and ABC Foundation acknowledges and pays respect to the past, present and future elders and traditional owners of this country and throughout Australia, and recognises their continuing connection to land, waters and community. We celebrate the continuation of cultural, spiritual and educational practices of Aboriginal and Torres Strait Islander peoples. So what are our learning objectives for today? Well, number one, we're going to understand what climate change is and how it differs from short-term weather. Number two, recognise how climate systems work and what is driving current climate change. Number three, understand how climate change is affecting country, ecosystems and communities. Number four, recognise the importance of observation, lived experience and evidence in understanding change. Number five, understand the roles of adaptation, resilience and mitigation in responding to climate change. And number six, gain confidence to engage in informed long-term decision-making about climate change and caring for country. So what actually is climate change? Climate change is the long-term shift in temperature and weather patterns. So climate is just the long-term pattern of weather in a particular area, while weather is the current state of the atmosphere in that particular area with regards to heat, rain, wind, etc. Current climate trends show warmer conditions and shifting rainfall, with projections pointing to continued change into the future. Some of those future predictions for WA by the year 2050 are increased temperatures by about 1 to 2.5 degrees Celsius, the number of days over 40 degrees tripling in a year, a 40% increase in the number of high fire danger days, and decreased rainfall. And all of this has been sourced from the Western Australian Climate Projections Summary document. So is climate change natural? These shifts can occur naturally due to changes in the sun's activity or volcanic eruptions. And over Earth's history, climate has drastically changed multiple times, which you can see on the graph to the right there, showing that as carbon dioxide concentration changes, so does the global temperature. But human activity is significantly contributing to climate change, which you can see circled in red on the far top right of that graph there. And this is what we call anthropogenic climate change. So climate systems, what are they and how do they work? So what is a climate system? Climate systems are complex, interactive systems that describe the movement of energy and matter containing five major components: the atmosphere, the hydrosphere, the cryosphere, the lithosphere, and the biosphere. So firstly, the atmosphere. It's a thin gaseous layer surrounding the Earth. It's important for regulating Earth's temperature, but is the most unstable and rapidly changing out of the five. And the composition of different gases affects how much light or heat can pass through. Some of those gases also trap heat, which are called greenhouse gases. So next is the hydrosphere. And so the hydrosphere comprises all of Earth's liquid water, found in lakes, oceans, rivers, underground, and etc. And it's also very important for temperature regulation. As water evaporates from these bodies of water, it collects as vapor in the atmosphere, which then cools down the surrounding areas and allows rainfall, which also drives the water cycle. Large bodies of water, such as the ocean or lakes, also buffer changes in temperature. This is because water is very good at holding energy, meaning places that are nearby to large bodies of water, such as huge lakes or the ocean, will tend to have less extreme temperature highs and lows. And for this, a good example to think of is the temperature differences in a desert from day to night compared to a coastal town, which might have a much more consistent temperature. So the ocean is the most important piece of the hydrosphere, as it's the largest part of it. it actually generates about 50% of the oxygen that we need and absorbs about 30% of all carbon dioxide emissions and captures about 90% of excess heat that is generated by those emissions. And that little link there is just the source for those pieces of data. Next up is the cryosphere, which the cryosphere is just all the water that is frozen as ice or snow. And the majority of it is either sea ice in the Arctic and Southern Oceans, or as land-based ice in Greenland and Antarctica. And ice and snow regulate the climate by reflecting sunlight back into space, which is called the albedo, which is just how reflective a surface is. Next up is the lithosphere, where the lithosphere comprises all land surfaces, such as rocks and soils, but also includes human-made surfaces, such as roads and buildings. And different materials absorb different amounts of light or heat, meaning more or less heating in that area. And lithosphere formations such as mountains can also redirect wind flows and change where rain falls. Last up is the biosphere, where the biosphere makes up all life on Earth, as living things play a key role in regulating Earth's climate over short seasonal periods, but also long time periods. As plants absorb sunlight and CO2, they lower global temperatures. But plants also buffer weather changes, reducing the effects of extreme heat, wind, and rain. So how are global climate and weather patterns driven? Together, these 5 components form the global climate system, which drives Earth's weather patterns. And the main energy input of the global climate system is the sun, through heat and light. And there's also some small influence from heat from the Earth's core, and also the gravitational pull of the moon. Sunlight hits and heats the Earth unevenly, causing atmospheric and oceanic circulation to distribute that heat. And as you can see on that image on the right there, you can see the angle that sunlight hits the Earth. And from this you can see the equator is heated more intensely than the poles are. And this imbalance causes warm air and water to travel from the tropics towards higher latitudes. And this effect, in combination with others such as the Coriolis effect, drive global wind and water movement. What actually is the Coriolis effect? Well, the Coriolis effect is just the deflection of moving objects that are not on the ground as they travel distances around the Earth, which is caused by the rotation of the Earth, as the equator is rotating much faster than the poles, where the equator is rotating at about 1,600 kilometers per hour, compared to 0.00008 kilometers per hour at the poles. And thus, objects are deflected to the left in the southern hemisphere and to the right in the northern hemisphere, which you can see demonstrated in those 2 images on the right. These wind and water patterns have major influences globally. They create something called the trade winds, which are consistent, permanent winds blowing east to west near the equator, and have been highly important in human history, especially for global trade routes. They also drive tropical weather systems, causing rainfall to fall on eastern coasts. And they have a major role in ocean circulation. And when they weaken, we get El Niño events, which means hotter, drier weather in Australia. And on the right there, you can just see images of the trade winds. The westerlies are the opposite of this. They're prevailing surface level winds blowing from west to east at higher latitudes, around 30 to 60 degrees, and in both hemispheres. They have strong effects on ocean circulation, carbon exchange, and weather. And they bring moist, warm, often stormy conditions to western coasts in winter. And they are much stronger in the southern hemisphere, but are much less steady than the trade winds as well. And climate change is already affecting these systems, with continued effects into the future. As discussed, the driver of these patterns is sunlight and heat, and climate change is changing how, when, and where the planet is warmed, which in turn affects weather patterns. The poles are warming much faster, which reduces the temperature difference between the poles and the equator. So, greenhouse gases. What are they and how do they work? Greenhouse gases are just gases that cause a greenhouse effect in the atmosphere. So they act like a blanket covering the Earth, and they trap heat in the atmosphere, which is one of the leading causes of climate change. And they have major impacts on human and environmental health. Here we're just going to have a look at some of the key greenhouse gases that you might encounter. So firstly, there is carbon dioxide, or CO2, which is probably the most common you would hear about, and the sources of this is deforestation, the burning of fossil fuels, and land use changes. The next most common is methane, or CH4, and the main sources of this are farming and agriculture, and landfill and waste. And lastly, we have nitrous oxide, or N2O, which the main source of this is fertilizer use, industrial processes, and soil processes. And that's just a little demonstration of what they look like. So what are the main sources of greenhouse gas emissions? There are natural sources such as volcanic events, wetlands, fires, living things, and decomposition. But there are also human influences such as deforestation, mining, fossil fuels, agriculture, transport, electricity and heat, and waste. And then there's something called a carbon sink. Well, that's just something that takes in and stores carbon. An important note is that land management can be a solution to rising greenhouse gas levels. Where good land management that is nature positive, leads to better carbon, biodiversity, and climate outcomes. And work like carbon farming and nature repair aims to reduce the effects of greenhouse gases and climate change on country. If you want more information on either carbon farming or nature repair, please look at webinars 1 and 2 for more information. And so while carbon storage or sequestration is important, stopping our emissions from ever reaching the atmosphere is much better, which is what we call emissions reduction. So while sequestration aims to reduce the amount of greenhouse gases already present in the atmosphere, emissions reduction targets the source, stopping those greenhouse gases from ever reaching the atmosphere. Yes, thus targeting the source. So how is country going to be impacted by climate change? So as we spoke about, climate change and its impacts aren't uniform. The impacts are going to vary with latitude, geography, proximity to oceans, elevation, and also socio-economic conditions. And some regions will be more affected than others. You might also see that some places might see the opposite effects of others. So the biggest one is uneven heating. As we spoke about, the poles are heating much faster than average. And so snow and ice that usually reflects light back into space is now being melted, meaning less light is reflected back, which in turn melts more ice, creating a positive feedback loop. There's also land versus water, as water redistributes heat much more efficiently than land, and interior land heats much quicker and experiences more intense heat waves. There's also going to be rainfall changes. So climate change intensifies the water cycle. Wet places tend to get wetter and dry places tend to get drier. This is what I spoke about, how places might see the opposite effects of others. And also an uneven sea level rise. The sea level isn't rising evenly, and this is due to ocean currents, gravitational effects, and also landform subsidence or uplift. But in general, in Australia since the year 1910, we've seen temperatures increase by about 1 degree Celsius. The number of days over 35 degrees Celsius has increased significantly. Rainfall has declined. There's a much higher fire frequency and intensity. We've also noticed some sea level rise, ocean temperature increase, and the ocean temperature is also more acidic now. Here I'm going to break down some of the effects that we might see on country by 3 different regions. with the first one we're looking at being the Southwest Flatlands. And so in general, in the future, which the document that these are sourced from references the year 2030, temperatures will have increased by around 0.8 degrees Celsius. The number of days over 35 degrees will increase from 28 to about 36. Annual rainfall will decline by about 13%. The number of high fire danger days will increase by about 5. And the sea level will rise about 0.12 meters. The ocean surface temperature is also going to increase by 0.6 degrees Celsius, and there's going to be an acidity increase of around 20%. And so what about the monsoonal north of WA? So they are going to expect a temperature increase of about 0.9 degrees Celsius. The number of days over 35 degrees Celsius increasing from 56 to 87. The annual rainfall will decline by about 10%, with there actually being a small possibility of an increase in rainfall. There's going to be uncertain changes to the number of fire danger days or the intensity of them. And again, the sea level is going to rise by about 0.12 meters. Ocean surface temperatures are going to increase, but it's unsure by what amount, and again, an acidity increase of about 20%. And lastly, the rangelands of WA, which makes up the majority of WA, they're going to expect a temperature increase of about 1 degree Celsius. The number of days over 35 degrees increasing by about 20%. An annual rainfall decline of about 11%, and again, a possibility of a small increase in some areas. Much harsher fire weather and more high fire danger days, but unsure how many. And again, a small sea level rise, an ocean surface temperature increase, and an ocean acidity increase. But how is human health actually impacted by climate change? Well, climate change and the associated increase in greenhouse gases in the atmosphere pose an immediate threat to human health. Firstly, there's air pollutants, or in this case greenhouse gases, that can irritate the respiratory system, which increases the extent and effect of respiratory illnesses like asthma. Rising temperatures can also increase cardiovascular strain, which can lead to increases in mortality, especially among the elderly. There's also a potential increase in vector-borne diseases. They could become more widespread, as higher temperatures allow insects like ticks and mosquitoes to thrive in areas they possibly couldn't before. And also an increase in the number of mental health conditions, as extreme weather and environmental destruction are direct links with worsening mental health. There's also likely to be reduced food and water security. Drought and extreme weather can destroy crops and livestock. And floods and heavy rainfall can contaminate water supplies, leading to increased food and waterborne illnesses. But First Nations people and those living in remote areas are more likely to be impacted. This is because they have a lower access to resources such as medical care, emergency response and disaster services, and also extra food and water. So what is the role of observation, lived experience, and evidence? Climate change is a long-term process, and having long-term observation data is essential if you want to understand true climate trends. And First Nations peoples and traditional owners have been observing countries for many generations. They have deep understandings of weather patterns, species compositions, fire management strategies, and land management strategies. Where two-way science and integration of this knowledge will help inform appropriate and adaptive management strategies, where this is known as traditional ecological knowledge, or TEK. And climate change mitigation incentives are increasingly beginning to recognise the value of TEK. Carbon farming methods such as savanna fire management integrate TEK into them. And nature repair projects can utilise something called culturally significant entities, which again, there's more information in the nature repair webinar. But the real value of observation over time is to understand the patterns of change that might not be visible at the scale of single events. And although different, these two knowledge systems both aim to understand patterns of change rather than just what's happening at a single event. The key point is that single events or changes don't tell the full story of what's going on, and long-term observation and finding patterns reveals much more about what's going on. Just a quick aside about climate resilience and adaptation. So climate resilience and climate adaptation are closely related, but not the same. Climate resilience is the overall capacity of the ecosystem or environment to survive, adapt, and thrive despite climate change. Whereas climate adaptation means adjustments made that are natural or human in response to climate change that benefit the survival of the organism or the ecosystem or environment. And a climate resilient country can withstand, adapt to, and recover from climate impacts, continuing to support people, culture, biodiversity, and livelihoods. It strengthens economies, so resilient infrastructure, agriculture, and supply chains reduce climate-related losses. It protects ecosystems, providing essential services like pollination. It also protects communities, reducing the effects of extreme weather events. And so how can we effectively respond to climate change? While adaptation and resilience target the effects of climate change, mitigation targets the root cause, greenhouse gases. So mitigation is human interventions that target the cause of climate change by reducing emissions or enhancing storage. Whereas adaptation means just adjusting to the effect that you're seeing of climate change. And resilience just defines how well the ecosystem can actually survive. And human intervention and mitigation efforts are key to preventing further ecological harm, where carbon farming aims to prevent further harm by either reducing the amount of CO2 entering the atmosphere or by capturing it out of the atmosphere and storing it. And nature repair aims to repair the damage that's already done, either by the effects of climate change or human development. But while land-based solutions play an important role in mitigating climate change, they do have their limits. Land-based solutions operate on long timescales, often taking decades to see returns. And climate change is threatening land systems which also store and cycle carbon, which is threatening to create another positive feedback loop of destroying the land and not being able to then restore the land, and it just getting worse and worse. And rapid emissions reduction will show the effects much quicker. So, making informed decisions under climate change. Why is decision-making under climate change different? Well, under climate change, there's more uncertainty in future conditions, there are long-term impacts and effects, and complex trade-offs. There are many challenges for the decision makers to consider, some of which will be specific to their case or area. And utilizing experts is a key to success. Some of the key challenges that you might see under climate change are uncertainty. So future climate conditions and impacts can't be predicted with 100% certainty. And so decisions must be made with the best available data. And also long-term impacts and benefits. So many land-based decisions have impacts that last years or decades. And so it may take many years to see the benefits of carbon farming or nature repair work. And climate impacts may also worsen over time. Another key challenge is having multiple objectives. So decision makers need to balance environmental protection with economic outcomes, cultural values, and community well-being. There's also the potential of irreversible damage, where some past land use decisions are very hard or impossible to reverse. And so infrastructure placement is a good example of this. It may completely block the repair that you might need to do in an area. So, what are some of the principles for making informed decisions under climate change? To ensure we're not causing further harm to the environment, there's some principles that have been outlined for climate-aware decision making. So, using the best available science, up-to-date climate projections, local environmental knowledge and monitoring data is essential. And plan for uncertainty. Consider multiple future climate outcomes and use flexible and adaptable strategies. You also need to take a long-term perspective and evaluate the impacts over decades, not just what's currently happening. Your outcomes for your project will also take time. Also, don't back yourself into a corner. Choose management options that can be viable under variable conditions. Nature repair and carbon farming require permanence, which mean responsibilities extend into future generations. Also, be precautionary. If there's a credible risk of serious harm, a lack of full scientific certainty shouldn't delay your action. If an action could cause serious environmental damage, act cautiously. And also prioritize actions with co-benefits, so that if climate impacts turn out smaller than expected, some benefits will still be received. For example, improving water or energy efficiency, or creating more urban green spaces will all have positive co-benefits. Now it's time to talk about how governance, consent, and intergenerational responsibility are all affected by climate change. Decision makers, like Aboriginal elders and boards, are the people who shape how country is managed. So free, prior, and informed consent, also known as FPIC, is essential for projects to succeed. Where FPIC is just the right of Indigenous peoples to make voluntary, well-informed decisions about activities that affect their lands, waters, resources, and rights. So carbon farming and nature repair projects can affect future land use options. This is because these types of projects have something called permanence obligations, which restrict certain activities like the removal of plant material. And this can restrict self-determination and cultural practices, reducing future economic opportunities and more. And the responsibilities of these projects extend to future generations. For more information, see the last 2 webinars. We all have a collective responsibility to care for the Earth so that future generations can inherit a planet capable of supporting life and well-being. And our actions today shape how the world will look for future generations. The resources are limited and ecosystems are vulnerable to degradation. So responsible land management ensures that future generations will have ecological, social, and economic well-being. Here we're going to look at some of the practical steps that you can take. Here are some practical steps to get started in your climate mitigation journey. The first step is always to assess your land's current health and carbon or biodiversity potential. Access some of the online tools and resources which will help with this assessment. Then identify some suitable carbon farming and nature repair practices. And lastly, connect with experts and access government incentives. One of the major grants or incentives is the ACCU scheme, which provides financial incentives for reducing your emissions or by storing carbon. Projects need to follow approved methods, and from this they can earn ACCUs for each tonne of carbon dioxide equivalent abated. And this is administered by the Clean Energy Regulator, DECU and DAF. And see webinar 1 for more information on the ACCU scheme. The next one is the nature repair market, which in a similar way provides financial incentives for nature repair and biodiversity improvements rather than carbon storage. But in the same way, projects need to follow approved methods. And in this case, biodiversity certificates are earned rather than carbon credits, which is also administered by the Clean Energy Regulator and DECU. And for more information on this, please see webinar 2. But what are some of the everyday actions that people can take? Well, every person on Earth has a role in reducing their own emissions. And so without emissions reduction, we could never achieve our climate goals. Some of these actions could include things like sustainable transport, like taking the bus or train, improving your energy efficiency, better recycling and composting, reducing your own waste, and prioritizing low emissions foods or locally sourced foods. So what are some of the key takeaways from today's webinar? Well, firstly, climate change is the long-term shift in weather patterns and is already affecting country. Climate change does have natural sources, but the major source is human activity and the release of greenhouse gases. Healthy ecosystems are central to climate resilience. Carbon farming and nature repair are one form of land management that can assist in this way. Climate change and its mitigation efforts, such as nature repair and carbon farming, are long-term strategies that may take decades to see returns. And it's important to plan for future uncertainty, being flexible in your land management activity. Climate change will limit future land use if we leave it unchecked, as it's going to destroy the land past the point where anything can grow. And just a quick little extra here, there's an interesting YouTube video. The name is The Weirdest Western Coastline Explained by Casual Earth. And this video just explains why WA's coastline is the way it is, which goes through some of the background science and information. And there's the link there if you're interested. But what's on next for the online workshops? Our next online workshop is the 8th of April at 11 AM. And the same as the last workshop, it's going to go through the background knowledge, science, and systems behind carbon farming in Australia. And if you want to check out our other events or webinars and sign up, please do so through the link on the screen, or any inquiries you have, please send through to the email. Our next webinar is going to be on blue carbon, and will release on the 15th of April, also at 11 AM. And this will just go through the background knowledge, science, and systems behind blue carbon in Australia. And similarly, you can sign up through the link on the screen or send through an email to that email address there. Thanks everyone for watching, and we hope to see you in our next webinars.